Okay, continuing with like our limits discussion, going to kind of recap last week. We talked about techniques for evaluating limits. And some of them, again, last week, they were all broken down. Watch those videos. They're really good so that you have an idea of the different techniques. One of them was the dividing out technique. Another one was the rationalizing technique. And that was kind of where you ended up multiplying by the numerator so that you could kind of cancel out square root signs, and then you could get a different denominator, because remember, we don't like denominators of 0. Then we talked about like using technology to kind of graph, so like finding, like graphing the limits and evaluating them using technology. And that also included looking just at one side, so one-sided limits, and comparing left and right limits. So again, looking at the graph, we had a few different ways that we could analyze those. So again, make sure that you are comfortable with evaluating those. And then we got into like straight up evaluating a limit from calculus. So, and I'm going to do an example of that, because that's kind of calculus, because that's what we kind of want to get to. That's kind of our goal, is to figure out how do we evaluate a limit from calculus. So let's say that we have the equation, the limit as h approaches 0, and it's going to be f x plus h minus f of x all over h. Now this is going to be pretty standard as far as like our base formula, kind of how do we start, how do we begin evaluating, and the function that we're going to evaluate is 3x minus 1. So again, the problem that I see is 0 here and 0 here. We can't have a denominator of 0. So I'm going to try to use some algebra to figure out how do I reduce this down, get it so that I don't have necessarily a denominator of 0. So what I'm going to do is I'm going to go ahead and I'm going to rewrite this equation. And so every time I see an x in my equation, which I only have one in this case, every time I see an x, I'm going to substitute in x plus h for this first part. So I'm going to say 3x plus h, and then I still have minus 1. So this is all the first sort of section. So let's call this our green section. So right here is what I'm doing. 3x plus h minus 1 minus, now I just have to plug in f of x, which we'll do that as blue, okay? So that's just minus f of x, which in this case is 3x minus 1, and all over h. So again, I haven't touched h yet. H is still the same. So now I'm going to distribute. I'm going to use the distributive property, and then I'm going to try to simplify. So I'm going to get 3x plus 3h minus 1 minus, I should have, just to remind myself, I really should put parentheses here because again, this negative sign gets distributed, minus 3x, let's not use parentheses, and then negative 1 times negative 1 is positive 1. So again, now that I only have addition and subtraction, I don't need my parentheses. And I can see that I have some like terms which very conveniently are going to cancel out. Now, Mr. Larson forgot to write it over h. So if we say 3x minus 3x cancels out, negative 1 plus 1 cancels out, all I'm left with is 3h over h. And again, I was being bad. I should have said the limit as h approaches 0. I should include that here. The limit as h approaches 0. And again, now I can see that, hey, I have h divided by h, which cancels out. So I don't even need, because I have no h's, there's no point in me substituting anything else. So the limit as h approaches 0 of this function equals 3 because I was able to cancel out everything else. All right, so that was a real quick review, again, of some of the different techniques. In this case, we divided out, we used algebra. I could check my work. I could go ahead and plug this into my calculator. I could graph it. And I could rationalize it if it had a square root sign potentially, or it had some type of denominator that equaled 0.